Today we are digging into a safety archive from 2007 to uncover some hidden dangers that structural engineers were warning about well over a decade ago. And these aren't just historical footnotes, believe me. They are absolutely critical lessons that are still incredibly relevant on construction sites right now.
So, our source for this deep dive is a single newsletter, published all the way back in April 2007. And yeah, technology has definitely changed since then, but the fundamental principles of structural safety and, all the ways they can fail, those pretty much remain the same.
So this specific document is the 6th newsletter from an organization called CROSS, which stands for Confidential Reporting on Structural Safety. Basically, it's a platform where engineers can anonymously share their concerns and, really importantly, their near misses from the field. And the idea for this whole explainer, it actually came from a structural engineer in the UK. They suggested, hey, why not use AI to make these older CROSS reports more accessible? We did. And honestly, the insights we found were just too important not to share. So that's exactly our goal today. We're going to dive deep into this one single report from over a decade ago and see just how timeless and how critical its lessons are for anyone involved in building, well, the world around us.
Okay, let's get into it. Here's how we'll break down the key dangers we found in the newsletter. We'll start with how materials themselves can deceive you. Then we'll look at what happens when on-site processes break down. After that, we'll zoom out to see what happens when entire systems just don't connect. And finally, we'll talk about the powerful call for shared knowledge.
First up, failures that come from the very building blocks of a structure. See, sometimes the danger isn't in the design at all, but hidden in the materials themselves. And our first case starts with something as small and as seemingly simple as a single bolt. So a reporter shared this story of a steel frame building that partially collapsed during construction. And the culprit? Well, it turned out to be these failing blind bolts, which gave way even under loads that were way below what they were supposed to be able to handle. Now, this is where it gets really interesting. Look at the huge gap on this slide. On the left, you have what was expected, strong, reliable bolts. But on the right, that was the reality. Tests actually showed the bolts had been hydrogen embrittled during manufacturing, which made them dangerously brittle. Get this, some of them even failed days after they were installed. Literally a ticking time bomb hidden in the steelwork. But it wasn't just bolts. The report also flagged this kind of creeping danger in older buildings, precast concrete planks. Turns out there was a chemical legacy, calcium chloride, which was added to speed up curing before the 1970s, and it was causing the steel reinforcement to corrode from the inside. This meant sections of the ceiling could just suddenly detach and fall with absolutely no warning whatsoever. Okay, let's move on, because it's not just the materials. It's also about how they're put together. This is where human process and, proper supervision become absolutely critical. So, take underpinning, which is the process of strengthening a foundation. It requires a super strict, methodical sequence. You work on sections that aren't next to each other first, like bays 1, 3, and 5, and you only fill in the gaps once that new concrete has had time to cure. Simple, right? It maintains the wall stability. But a reporter arrived on one site to find this sequence had been completely ignored. An unsupervised worker had excavated 3 of the 5 bays at the same time, leaving 60% of the wall just dangerously unsupported. And why? Because the right materials for the next step hadn't arrived, so he just got on with the next task. And this just brilliantly illustrates the reporter's main point. You can have a complex, engineered sequence that's designed for safety, but it can be completely undone in moments by one person who doesn't get the why behind the instructions. It just highlights this terrifying vulnerability in any safety-critical task. And this vulnerability, this on-site process failure, it popped up again in a report on scaffolding. In one incident, a scaffold that was being taken down just suddenly pulled away from the building and collapsed. The human cost of that failure? Three scaffolders were hospitalized. But the danger didn't stop at the edge of the construction site. The collapsing structure fell right into the street, and it completely crushed a car. The number of people from the public caught up in this failure? 1. It's just a stark reminder of who is at risk when things go wrong. So the crucial point here, as CROSS notes in their commentary, is this. The temporary structures we build to help put up the final building, like scaffolding, they are not less important. They demand the exact same level of engineering rigor, planning, and supervision as the final work. So now, let's zoom out even further. So far, we've seen failures in materials and in processes. But what happens when the failures are actually embedded in the entire system of design, supply, and regulation, long before anyone even steps foot on a site? A reporter raised an alarm about a growing trend: these low-pitched metal roofs. Because they're so much lighter than traditional tiles, wind doesn't just push down on them, it creates this incredibly powerful lifting force. I mean, as you can see, the uplift pressure can be over 4 times greater than for a heavy-tiled roof. That's a huge deal.
But the problem wasn't just one person's mistake. It was a cascade of system failures. The truss design software, it wasn't accounting for these intense uplift forces. The roofing contractors were using screws that could literally split the trusses. And crucially, the truss supplier, the roofer, and the main building designer, they just weren't coordinating. Everybody was working in their own silo, creating this massive collective blind spot.
And this lack of clarity, it went all the way to regulation. Another report highlighted confusion over the enforcement of CE marking, which is a quality standard for structural steel. The reporter was worried that without clear policing, lower quality and, let's be honest, potentially unsafe products could easily get into the supply chain.
So when you look at all these reports together, the brittle bolts, the unsupervised underpinning, the disconnected design teams, they all point to one really powerful conclusion: the immense value of a program like CROSS.
See, CROSS exists to capture exactly these kinds of stories. It's not about blame, it's about collecting the lessons, the concerns, the near misses, and the trends, so that one person's scary experience can become a lesson that prevents a future failure somewhere else.
And the benefits of creating this shared reservoir of knowledge, they're just enormous. By sharing information confidentially, the entire industry gets smarter and it gets safer. It leads to better quality, lower costs, and, most importantly, it can reduce deaths and injuries. It is a system that's designed to build a collective intelligence against failure.
And this really leaves us with a final and pretty crucial thought. Every engineer, every builder, every site manager, they all carry experiences with them. This 2007 newsletter is just a powerful reminder that the knowledge to prevent the next disaster might just be locked away in a near miss that someone hasn't shared yet.